Hi, my name is Malachi Dahan. I designed and printed a custom Sieve for the Land Institute, a nonprofit agricultural research organization that develops perennial crops. David Van Tassel, a lead scientist at the Land Institute, who breeds Silphium, needed a more effective method of cleaning his seed so that he could calculate the yield of individual plants. Due to the unique shape of Silphium seeds, traditional sieves don't work very well. My sieve should make the cleaning process more efficient, saving time when cleaning hundreds or thousands of samples.
Well, I'm trying to take a native prairie plant and do something that hasn't really been done before, which is to take a native North American prairie plant that's a perennial and turn it into a food crop that we can use as an oil seed. So perennials are an idea that we want to try because when we disturb the ground too much to plant seeds every single year or multiple times a year, the soil becomes damaged and it's much more vulnerable to being blown away by the wind or washed away by water. We harvest seed from thousands of individual plants every year, and the most important thing that we measure on each of those plants in our breeding nursery is the yield of the seeds. So that's why we spend a lot of time trying to clean each sample. And that gives us the data that we can then use to select between all those thousands of plants and figure out which ones had the best combinations of traits. We've been working on this plant and making progress, changing it in certain ways genetically. But because it's a wild plant, it happens to have strangely shaped seeds that are pretty big for a wild plant in terms of just the weight, but they're also flat and they blow in the wind very easily, and so that makes it really hard to clean them. We've tried all kinds of things, all kinds of sieves, different shapes. Some of the sieving equipment is just a pan that you shake. Some of it is it has a shaker, and they make slots, they make triangles, they make round. They make things that are at angles. The slots are at different angles, and I've tried all of those. And either too many things go through, or too few things go through.
Well, it started out with me meeting with David at the Land Institute. He gave me some ideas. They were originally not a tumbler design like I have now. They were all designs for flat sieves. I went home, hacked some together, printed them off, tried a few various different things, took the parts from different ones that worked the best, put them together, and then made a tumbler design for agitation. The unique characteristic is these V-shaped ridges that cause the seed to stand up on their side, and then they'll slide down through that slot much more easily than just a flat pan style sieve would. The lid here has magnets in it that allows it to just snap down on top of the sieve, keeps everything from falling out. The spinner also has magnets in it, so the sieve attaches and comes off really nice and easy. The spinner is really very basic. It's just a motor, got a shaft with a bearing on it. 3D printed the mount for the bearing, and this plate with the magnets in it is just connected to a PWM motor controller.
I've said, I've tried many different things for many years, and usually the thing that's worked is just doing a whole bunch of different things very tediously. And so having one piece of equipment that could really take advantage of the unique shape of the seed and use that as the way to actually separate the seed out from a bunch of other kinds of things feels really exciting, and I think will be a game changer.